Hello, and thank you for listening to this episode of the Night Sky Podcast. My name's Billy Newman,
And I'm Marina Hanson.
and we are going to be talking about some of the things in the evening sky and morning sky for the first week of March of 2017. And we had a couple things to catch up on, like some things that had happened, I guess, in the past couple weeks of February. Let's see, what did we miss? There was a lunar eclipse.
Oh, right. Yeah. I don't think that was really in our viewing, but
Yeah,
yeah, it did come
I think
through.
it ended up happening for people that would have been out in the Atlantic Ocean, and I think for a good bit of the eastern seaboard over
Mhm.
here, I think most of the East Coast would have seen it. And then
And what kind of eclipse was this one? Because it was
that's a good
different.
question.
It was a different kind than the one that we're gonna have. Like we're gonna have a total solar eclipse in August,
Yeah,
but this one was this one a total solar eclipse or
well,
was
this was
it
a
not?
this was a lunar eclipse of just the moon. I think is what it was. Yeah, so it was just the moon being
Oh,
dark
okay.
on the East Coast as the full moon rose up above the horizon. So that's the big difference that it would be for that. And then I think well, I think it might have been only a partial. Maybe that's just what it was for us on the West Coast, because I think is what I had understood is, or maybe what I was most concerned with was what it would look like to me when it came up. But I think they were
Right.
saying that it was going to just be in the penumbra at that point. So I'm
So
sure
if you're in the right spot, maybe it was a total one.
I'm sure that seems to be how it works for the moon most of the time. Is that like some if there is an eclipse somewhere is getting like the total eclipse, because it's kind of like the Earth's shadow is so big that it's a lot easier for that to cast the moon into darkness for a period of time more than it is just the moon's smaller shadow cast down onto the Earth,
Mhm.
like it would be for a solar eclipse. So that's where like the whole Earth or the whole half of the hemisphere will see that lunar eclipse, whereas it's more difficult to see the solar eclipse if it's
Right. Yeah.
happening during that day. Kind of interesting how that is, but yeah, it was kind of cool. I think I remember one. Well, actually that was kind of early February that we had it. Yeah, so I was trying to figure that how that was, but it always does seem that we have the lunar eclipses a little closer to the equinoxes. Have you kind of
Oh,
noticed
that's
that a little bit?
interesting. Yeah, I guess so.
It seems
Or
like it's
thinking
in
back on it, it
September.
seems like that's about when they seem to happen.
Yeah, I seem to remember trying to watch them in September, October, or like February, March, April a lot of the time. So there's still some more mysteries about some of those draconic cycles and like how the eclipse cycle for lunar eclipses go. I just don't really know all the intricacies of it, but it seems like that's one of them, or that's kind of strange, like why the lunar eclipses seem to occur so
At
often in
those,
that, yeah, in that
yeah, in those
section.
time periods.
Like a few years ago, we had the tetrad, where we had like the four in a
Yeah.
row, and those were all
Hmm.
like, you know, uh, like fall, spring, fall, spring.
Right.
It's interesting how that goes, but it seems to be like my recollection for a long time. So there's the lunar eclipse. What else was there? There was the exoplanets. We found the exoplanets, like the NASA, I guess, announcement that scientists for a long time had discovered, and then had been doing more work to verify that they had found. How many planets was it?
I think it was 7,
Seven. Yeah,
or they had already found. They had already found 2 of them,
that was kind of my understanding too.
and then
Yeah,
they found 5 more.
yeah, they found a few others in the system, and I guess they say that a few of them are going to be within that Earth temperature range where it could have
Right.
liquid water.
I think that they're about Earth size also.
Yeah, I was trying to figure out what that meant. Or I guess maybe, yeah, it means that they're Earth size. They probably would have to be
I think
about
that's
that
what I had
big.
read.
Yeah, it's probably true, because I was trying to figure if that was in relationship to the size of its sun, which was smaller, but I don't think it is. I think it is the mass size of Earth, but I guess it's all closer
Yeah, that was
into
a
the sun.
really interesting part of it too, is that I think they're all about the same size, which is Earth size.
Wow.
And I think that they're really close together.
Oh, that's interesting. Yeah.
Yeah, I had read in the I guess the NASA report of it that they had put out, that like if you were standing on one of the planets,
Yeah.
that you could look out and see one of the other planets and it would appear in the sky larger than our moon appears to us.
Really?
Yeah.
Wow.
Doesn't that sound crazy?
That
I
sounds
can't imagine looking out and just seeing a few planets lined up
yeah, that
that
would be so
big.
crazy, just like big planets, or like if you were if you were a species that like grew, if there were two different cultures on these different
Oh
planets
yeah,
and you'd
that
like
would be
look out and
crazy
see them
too.
before you could communicate or see each other.
Yeah, cuz like we can make out definition on the moon
Yeah,
with our eyes.
yeah,
And you I was it had said something about how like you'd be able to make out geographical things or
yeah.
like
You could see
landmarks and things and
weather.
you could see the weather
You could
and
see the
stuff.
ocean. You could see like big
That would be
big
so
hurricanes
strange.
wrapping up onto the coast or something. Like how strange would that be? Like you can look out and see that
Yeah.
sort of thing. It'd be so easy to get to too. You
That would
just
be cool too.
go
Yeah.
interstellar right away.
Yeah, I wonder how it would work.
Yeah, it'd be cool. I think it was 40 light years away, or maybe 39 light years away. Was it TARPIST?
I think it's
TRAPPIST?
TRAPPIST. I think it's
TRAPPIST-1?
TRAPPIST-1.
TRAPPIST-1. Was it in Aquarius? Or I don't know. I don't really
Uh
know that part of it. It
I
was
think
somewhere
it
distant.
yeah.
But 40 light years away is really pretty far. There's a lot of stars that are closer than 40 light years. Like I was thinking about Vega is like
Oh yeah.
26 light years. Uh, I mean, there's like Sirius is only 8 light years. There's like Proxima Centauri. It's like pretty close. That's down in the southern hemisphere. But there's like a handful of stars that are really a lot closer. There was another star that they had found last year that I think it was Proxima Centauri. The closest one to it has a planet that goes around it.
Oh.
I don't know if it's as likely to have life or be in the Goldilocks zone of a star, but it was interesting that it had a planet next to it, which is I think 4.2 light years from here, which would really take a very long time for one of our conventional spacecraft to travel through space at that speed. But it'd be really interesting. We could probably, I mean, if there was focus on it, you could do it in the next 50 years, maybe send something out in that direction. But it's kind of interesting though the idea that we know that there's like an exoplanet nearby that you could study something about. But that's also tricky too because we've just, I think, in the last year or two, figured out at least the things we know about just in our solar system. And we've only done that a small amount. Like we've only sent like one probe out to each of the planets, or more than one
Mm.
probe, but not that many. Maybe we won't jump on sending stuff out to other solar systems right away. But it's cool though that they've done so much research in exoplanets and
It's
found that
yeah,
out.
it's really cool. It's interesting. How is you had explained to me a little bit how it works, like how they identify that they're there.
Yeah, the science of this has evolved a little bit, if I understand right. It was 1995. It's really a modern science, but before that, they were looking for the signs of planets going around other stars, but it was really just theoretical. Like it was the ideas of Star Trek that had planets around it, but it wasn't really in science understood if there were really planets that could go around other stars other than ours. And it wasn't just something we could observe because planets were so, I guess, difficult to observe at those distances. So we had to create really sensitive, uh, complex equipment to do analysis of a star. I guess with just big telescopes. I think when we put them up in space, when they were like still enough and able to take like like really long exposures with the really big mirrors, so they could
Mhm.
collect a lot of light from these distant stars. But I guess what they were doing was they would watch the star. This was in the early days. They only had like the ability to find really specific examples of exoplanets. So that would be anything that was like a small planet, like a small Pluto rock or a Mercury rock going around a big star. It's not going to make much of a big difference, and it would be just hard to detect for us. So the only thing that we could really find were big stars that had really big gas giants, like Jupiter-sized gas giants, things that maybe should have just become a double star, like a second small star next to it. But like these really big gas giants that were out just right next to the sun or right next to that star, like somewhere like in Venus's orbit, if we were to imagine like a giant Jupiter sized gas giant next to the sun, like but so close to the sun. And the reason we could detect those is because they had such a big separate mass that as that planet swung around the sun, its gravitational pull would kind of swing it around, so you could see the planet wobble a little bit as you watch the precession of the planet
Okay.
and its revolution around
So you could
its host
see
star.
that there must be something else that was affecting its movement, and that's how they would
Yeah.
identify to look for there being
Well,
something.
I think that was their proof in a lot of ways. Like there's a lot of complexity in the physics and the math that they're using to say that this is proof. I guess it does check out. But yeah, I think that was the original understanding, was that these wobbles in the star had to be caused by some kind of object. Now, I don't know if they've really been optically observed. I don't think there's really any kind of technology that allows us to optically see that there are these planets. Isn't that strange?
That is strange. Yeah, it's so interesting being at a point where we have equipment and processes for
Yeah.
being able to know that things are there that we can't see,
Yeah,
that are
it's instrument based.
impossibly far away from us to
Yeah.
be able to
So
identify.
far.
That's crazy.
So yeah, everything that we see online are all artist renderings of this concept, which is
Right.
always so misleading and confusing, because you wonder, like, they got great pictures of it right away, given that we don't even have pictures of Neptune or something, or
Yeah.
whatever it is. So it was just silly. Like, sometimes when you think, like, huh, really? Like, what? Or yeah, where do these pictures come from? But so really, yeah, it's just all instrument based. Like it would be if you were flying in a plane in a storm or something like that. A pilot's still supposed to be able to judge and see everything that's happening, but without the aid of the
Actual sight.
visual, like the optical part of it. They just have to trust that the truth is there because of the effects of these instruments. It seems really strange to me. But so that's how it was in the beginning. I think when they found the first exoplanet, was like a really big one going around a bigger, or a star that they could see the wobble from.
Oh,
I
okay.
think it was easy to detect, but it's gotten more refined now over the last 20 years. And so now we're at a point where we can detect what it was that we saw, or the NASA scientists discovered and then published papers on, I guess, a couple weeks ago. We now see that we can find small sets, and I think this is the first like solar system that's been confirmed, or first
Yeah.
small, like many small planets, Earth-sized planets, a couple of them being, like we said, in the Goldilocks zone,
Hmm.
where you could have,
Potential life. And
yeah, liquid water, something about like liquid water
hmm.
and like carbon. I think, like we were talking about this morning,
Right.
like if you have that, then you can, and heat. I guess it's kind of like you can get organic chemistry going that way. I don't really understand how that gets started though. That's another podcast, I guess. But yeah, it's really cool though that they have like another solar system to observe now with 7 planets. It's probably going to be a point of research for a long time. But maybe now that they have the sensitivity to discover these things, we're going to see them discover a whole number of other star systems that are out there,
That have
that have
exoplanets
planets.
also.
Yeah, just solar systems that are out against all these other stars that we've learned about.
I'm sure. Or I imagine there must be a lot more.
You
If
know,
we found one
yeah,
other one and we're here, I bet there aren't just two.
yeah. That's a really exciting thing about it, is that yeah, it was wondered for a while if really big stars with solar masses much greater than ours, if they would even be capable of having stars, because like they would suck all the material in
Oh,
originally, and maybe that might be the case, or I'm not totally sure how the physics work around the different sizes of stars. But it might be like that there's a range of size that has more planets, or is more likely to
oh.
have planets stay out of it, or
Hmm.
maybe there's a range where it's really big and you wouldn't have planets. I don't know. It's kind of interesting, but it's really interesting to see that we're now getting to that stage of what I'd heard before. I think when I was in college, I had just taken like the basic astronomy class, but they had talked about how most of the work in astronomy science today, the research that's getting paid for, is the search for exoplanets, which is kind of interesting. Well,
That
interesting,
is,
like what we're talking
it's
about.
yeah, it seems like a pretty fascinating thing to try to discover and learn more about,
Yeah,
especially with like this one with TRAPPIST-1, and the planets we found on it. Like one of the things that we've learned is that a few of them are potentially um, potentially planets that could have life,
yeah, it's really
which
interesting.
seems
It's
like
super
something we
exciting.
would want to learn more about for
Yeah,
other stuff. So
absolutely.
it's just yeah, it's a really cool
Yeah, so
thing to be.
that and the opportunity that there's other stars. Yeah, it's really fast. It's really cool.
How big is oh, I don't know if you know this. How big is TRAPPIST-1 compared to like our sun? Do you
I
know
heard a
how much?
little bit about this. So it's interesting how everything started. So we're humans, we live on Earth, and we've sort of set everything up with the understanding of what's been around us. So
Mhm.
when we say one solar mass, that's the unit for the mass of our star. We've just kind of given that
Oh,
as like
okay.
our sun is one, what's
Okay.
that compared to other stars as they go out? It's 2 because it's bigger, or it 147, I think, is the biggest one we've observed.
Oh wow. Which
147
which one
solar
is that?
masses. I don't know. I think it's
That's
way out. I don't
giant.
know if we see it all the time,
Oh.
but yeah, that's a nice one. Talk about like the main sequence and things that go crazy on the main sequence is those big. Well, that's where you get like crazy black holes. It's like super super heavy ones. I actually I don't know, but but so back to ours. That's one solar mass. I think this one and ours is like a yellow star. I think it's
Right.
actually a green star. I don't. I've heard that. That didn't really make sense to me all the time, but it's so bright that it kind of blows out our ability to see it, so it looks yellow. It's been confusing. It didn't really make sense, that explanation to me. It seems like a yellow star, but this one is like a brown dwarf star,
Oh.
or it's a
Oh, I had read something about that. It's like a super dwarf or something. Super might not be the right word, but it's
super dwarf.
I
Yeah,
can't remember what it is though, but yeah, that's like shoot. Gotta look at that NASA article again.
it was
But yeah,
supposed.
it was like a super dwarf
I
something
heard
or a
some
super
comparison
cool.
of it and Jupiter, like 10 times bigger than Jupiter, 5 times bigger than Jupiter, which is still kind of
Okay.
planet sized or something, which
Yeah.
is a really small star. I mean, like Jupiter is like, and then the sun is huge next to it. Um, but, but yeah, I guess it was this dwarf star that's a brown dwarf. It just means it's cooler. It's
Hmm.
cooler in temperature and it doesn't have the mass in it to have, as hot of a fire going. I guess there's a lot of stars like that out there. But it was kind of interesting though, yeah, hearing that it's like smaller and then all of the planets are a lot closer to it because
Right,
like
yeah.
that
I guess it's cooler, so
yeah,
it can be.
right, yeah. What was it, like Mercury's orbit? It was something like that. Everything's kind of within
Oh, it's
Mercury's
right in
orbit
there.
if we sort of
That's
placed
interesting.
everything back together. Yeah, really fascinating. Yeah, it was kind of cool. But yeah, so that exoplanet discovery was pretty cool. There's a few other things that been moving around in the morning. We've had like just a couple. It's been rough, right? Like around here
Oh
in
yeah,
the
with
Eugene area.
all our clouds.
It's been so
So
rainy.
overcast and
I
rainy.
think it's been more rainy this year than it's been maybe the last 2 years that we've been here.
It seems like it.
A little bit
Seems to be
more
lasting
snow
longer.
earlier in the year. A few more, like, yeah, a lot more rain. It seems like we've had, like, well, California had a good bit of flooding in areas where, like, the last 2 years or a year ago and the years before that, there was
Oh
a
yeah,
severe
the
drought
drought.
where they're out of water. Like, but now all the reservoirs are up. The dam was about to burst. Here out in the fields, there was a lot of backup water. And
Tons of flooding. Yeah,
yeah,
we've had I guess very minor flooding. It's not really no
yeah,
roads or anything, but yeah, a
the
lot of
water was up.
flooding around people's houses and stuff. A lot of like the valley farmland
Yeah,
around here.
yeah, I saw a lot of that, and yeah, a lot of heavy rain. But there's just been a lot of consistent, sustained rain
Yeah.
and clouds and storms and stuff. At least for our efforts of doing sky watching pretty consistently for the month of February. But we did get away with a few nights of observation and mornings where we get up and go to the window that looks out to the south sky. And I think it was just a couple mornings ago, but we went out and it was cool noticing that we can still see Jupiter up next to Spica and the constellation Virgo as it's getting closer over to the western horizon as the sun starts to rise, which means, which is really cool, that we're going to see it up maybe around midnight or 11 o'clock really soon. Coming up in the evening sky,
Oh yeah.
and then yeah, coming up toward its position of opposition, probably if it's in Virgo, sometime around I think May, maybe sometime around then is when we'll see it coming up over the horizon. Um, but so it's cool seeing Jupiter in Virgo up next to Spica. But what's better than that is like dropping back down, you see Scorpio now up past the sun in the morning sky. And I could spot Antares, but most everything else was too dim by the time I was looking that morning. And then if you go a little further back, you can spot Saturn, which is still up. It was kind of like close to the horizon line, but you can see Saturn now a little bit closer back to the constellation of Sagittarius, which was interesting. Like, remember the summer when we were looking at it?
Yeah. It's interesting seeing it move.
Yeah. So this summer when we looked at it, we saw Saturn in Scorpio, and now with its prograde motion, it's moved back toward Sagittarius, and it's like 29-year cycle. And so I think like by the summer and fall, it's going to be right up next to the galactic center, which I think is going to be kind of cool to look at through a telescope or to do astrophotography of, just because there's going to be so many active things.
Yeah, right in that spot.
Yeah, right behind it. It'll
That
be
would
kind
be
of
really cool
interesting.
looking.
I don't know if it could be exposed for. It seems like
We gotta
maybe
try.
it would be different, but yeah, it was kind of a cool thing. That was sort of interesting. I guess it would be
That's
in opposition sometime around July, maybe July this year. So it'll be a good summer start to keep an eye on. I think it'll be pretty fun.
yeah,
Um,
that'll be a cool one to
the
watch.
other cool thing I was thinking about was when, if we remember that Saturn's year is 29 years to do one revolution around the sun. I was thinking about that because I just turned 28 a few months ago, and I'm coming in, and you're kind of coming into the last lap, the last leg of the lap of the year 28, with Saturn now as it comes into 29. Forgive our our heaters in the back. But as we both come into like the year 29, it's interesting to think how my whole life is just one trip around the sun if you were on
Yeah,
Saturn.
that's so interesting to think about. It's neat that it's wrapping back around to right in the spot where it was when
Yeah.
you're born. That would be interesting. I guess it's kind of lined up there now, roughly,
Yeah,
for how
roughly.
much it's going to move over the next few months.
Yeah, it seems like it's like half a constellation a year, something like that. So I guess it would
Preset.
take to do 30 years of it. And then like for you, like Jupiter's gone around twice in your
Oh
lifetime.
wow, yeah.
Yeah, Mercury's gone around like I don't know, way too many times. I couldn't count. It was like 80 times or something like that. What,
Oh
a
wow,
70-day year? Who knows?
I'd be so old on Mercury.
So old on Mercury, Marina. Oh no.
That's a really interesting thing to think about, or
Oh
especially from
yeah.
our, because I think about my Earth year.
Yeah, yeah. I think yeah. You think about that time that you've had. Yeah, it'd be really strange. Gosh, be like the longest, slowest part. But yeah, I thought that was kind of neat looking out to Saturn. Moving around to the evening sky, we were looking out. We did another observation night just a couple days ago.
Yeah, we got lucky. The sky was clear for a
Yeah,
few.
that one was pretty satisfying. Yeah, we drove up and we spent a little bit of time up on the side of the hill looking out to the western horizon, and we were trying to make some. Well, I mean, right now it's really easy, but making some good observations of Venus. It's so bright right now. Still,
Yeah, it's still so bright. It
it's
really,
been really cool. Watching it over like the last month. I think like in January we were commenting about it a lot as it was moving up into the negative 4.6 threshold of its magnitude, which I think is sometimes the brightest that you can see it. In the month, it's moved down a bit, but it doesn't seem like really too much. It still seems like it's in the threes, at least negative threes
yeah,
magnitude.
yeah. There's been enough time between us actually being able to observe it that I don't know if I could notice a difference.
I
Like I
know.
feel like it seems as bright as it did
Yeah, it's
when we were
really
first
bright.
looking at it. It's still so.
Yeah, it's super bright right now. But what's interesting and what we were looking at is that motion that it's making down to the horizon over the next couple weeks.
Yeah, it's interesting that because it's moving down a lot faster than it was moving
Way
upwards,
faster.
right?
Yeah. Yeah, it's been really strange. In fact, like if you were to go out tonight, it's probably already moved a little bit since a few nights ago when we looked at it last. But if it's the third right now, we were looking at it maybe the last couple of days of February. It's probably moved down a good bit by now because it's going to be gone. If it's March 3rd right now, it'll be out of sight, like so close to the sun that we won't really be able to see it before everything's set. It'll be about March 23rd or 24th, but it's going to move in the next 20 days. I guess is what that would be. So we're going to see it from the position that it is now in the evening sky, and it's going to drop all the way down to the sun in the next 20 days.
It was
That's a
so fast.
yeah, that's way fast.
When how long is it going to be gone or out of our sight? Are we going to start seeing it in the morning
Yeah,
next?
that's an interesting thing because yeah, that's how part of the motion of Venus works, and it's really interesting. There's a few parts of that I really want to like spend some time unpacking with you. We can do it in the future on a bunch of other podcasts too, because Venus has some really interesting movements to it that have been important to a lot of different cultures and stuff. I won't get into a ton of that right now, but it's cool because Venus has this 5/8 ratio to the Earth, I think is what it is. That's really steady And so the times of years that we see Venus come up and the cycle that it takes repeats like clockwork almost. I guess it's 99 full moons to the day.
Oh wow.
Yeah. So whatever that means, I don't know why that is, but I guess they said like if the full moon and Venus showed up on the first day of the year, it would be that exact way 99 full moons later. It would look the same way on that day, and it would be 8 years later. I guess that's how long 99 full moons takes.
That's interesting.
Yeah, but so it has this 8 year cycle where Venus shows up in the sky 5 times. So it has more years than that, of course, because it's moving faster around the sun than the Earth is. But when we see it appear in the sky, like we have in the evening sky now, what was it, since June 1st? Say something like June 1st. Like you can get like a Star Walk or one of the other planetarium apps where you can kind of like see the motions or like where the planets are now and then where they were like 6 months ago, like what we were doing the other day. You can go in and roll back time to like say like June 1st, June 15th. And if you look at the position of Venus against the sun on the western horizon, you see that it's right there next to the sun. But it's probably around the first week or two that you'd be able to see Venus above the horizon in the evening sky as the sunset. And so I think it's interesting because that for this time has been up since June 15th, now up to our current time in March, only for 3 more weeks till about March 24th. And then it's gone back to the sun. So it's like a 270-day period. Crazy.
Well, yeah.
And so that's, I think, like it's longer period in the evening. I haven't done enough research to really find out what it's going to do in days for the next period when it shows up in the morning. But what happens next is interesting, is that after that 270-day period, it comes up at this time of year, like we saw, if we're keeping track of this 5/8 rule, like we saw 8 years ago in 2009, which I kind of remember, but I don't really remember what Venus was doing. It would be in the same position as it was 8 years ago, the planet Venus. So as we look out now, we see it up against Aquarius as it's moving back down the sun when it's really close to the spring equinox or the vernal equinox, autumnal and vernal, right?
What are would you I think so. What are the definitions for those?
For autumnal
For
and vernal.
autumnal, yeah.
Autumnal is
Like
autumn for fall equinox.
right. What
Vernal is the spring equinox.
oh, okay.
I don't understand what other etymology vernal has, but yeah, I think that's what it is, the vernal equinox.
Okay.
And so as we're coming up, so okay, so this goes into the other thing that we were looking at. I'm trying to keep it all straight in my head. It's a long
That's
way
a
to say
lot.
the movement of Venus, but it's so complex. It's so strange, and I think there's only a handful of different motions, different tracks it takes in the sky in certain seasons. Um,
Oh, yeah, that was an interesting part of looking at the because we were checking it out on the Star Walk app when we
yeah,
were looking at it in real life.
yeah,
But we were going through time and we were watching the way that it moves. It was really interesting seeing that shape that it seems to make.
yeah. So over a year, like if we were looking at the sun, I think that shape's called an analemma. So and that's the motion of the ecliptic. So if we were to take a picture of the sun, I think this is what they did a while back. The book I was looking in, it was like from the 1700s. It was in the Library of Congress that someone had taken a scan of, but it was one of these early analemmas that had like a bunch of kind of like a peachy folder. Do you remember when you were a kid, you
Yeah.
had a peachy and it had like all these like important stats on the side? It was like a book of those things. I guess
Okay.
before you had computers, you needed or Google, right?
Hmm.
You needed like a book that had like kind of
Database book.
the data for all these little things, and it was like like analemma match like things and almanacs and little different pieces that were all kind of fit together in this big book. But this analemma is a shape, is a word that describes the shape of the ecliptic and the position of the sun. This is kind of a big term to unpack too, but you've seen it before. It's kind of this infinity shape or this figure eight shape that's sort of lopsided. It's heavy to one side. And what that is like if it was at 6 p.m. and we were out on a bluff looking at the western horizon and we saw the sun there. And we came out every day for the next year at 6 p.m. and we took a picture of where the sun was, saying that it, I guess, was up at the time. What you would see if you stacked all of those images together for the year, if you took them in the same spot, you would see this kind of figure eight shape of where the sun is at that time. And what that shows is the motion of the ecliptic from our position on Earth. And it all goes back to the way that the Earth tilts down toward the Tropic of Capricorn in the winter, and then up toward the Tropic of Cancer in the summer, that 23.5 degree tilt. Do you remember
Yeah, I think so.
that? Yeah, it's so silly. So yeah, so what causes the seasons to go back and forth causes the ecliptic line, like where we see the sun, to go up and down. And so like in the winter, if we relate it all back to the sun for a moment, in the winter, as the sun's low on the horizon, we get less light. It's cold for us. In the summer, it's high on the horizon. We get a lot of light. It's hot for us. This also affects the position of the planets and the signs in the zodiac, I suppose, uh, as the ecliptic moves through the night and through the season. So what we look at when we look out, or when we look at this analemma, is a representation of the movement of the ecliptic through the year as it moves up toward the winter solstice, then down toward the vernal equinox, then to the summer solstice, then to the autumnal equinox, and then back again to the same position it started at.
That's really interesting. I hadn't. It was cool seeing it on, or just on the little app because I didn't.
Yeah, it was cool.
It's cool being able to visualize it
It
in
was
a
way
more real
easier.
way. Yeah,
Imagine how many years it would take if you just had to look at this stuff for the first
I
time.
don't know how you'd figure it out. I don't know how they did it.
I don't know how they did it at all either. But what I'd recommend is anyone listening to this and hearing me trying to explain this, just go look at it. You'll probably remember it, seen it a ton of times. You know more about it than I do already. Uh, but yeah, the analemma is kind of a cool figure, but that sort of describes what's happening with Venus and why it's moving so quickly down toward the horizon and the sun right now. So if we think about the time of the year when the length of our day changes the most, it's when we're closest to the equinoxes. So for us in the northern hemisphere, right now, what we're experiencing, our day is getting longer, faster than it had before because we're getting closer to the equinox. And then it's going to slow down. It's going to come to a standstill when we get closer to the solstice. Kind of interesting.
And
So
that's. Oh, I'm sorry. That's why we see the warp in the shape of the figure eight.
yeah, that's why. Yeah, we see like I I think the warp in the shape might be because we're higher up on the northern hemisphere. I'd wonder what it would be if we took observations of it right at the equator,
Oh
if it'd be
yeah.
even, but we'd probably still see it wobble to some amount. I wasn't really sure about that, but we do see uh, the that it is not like an equal shape,
Hmm.
but it seems to be kind of stretched out. And so yeah, that's what we do see in the shape is that it transits much more distance. If we were to look at the image of the analemma, this figure eight shape, it transits a lot more distance on the straightaways as it would be, and then
Hmm.
kind of like a car on a racetrack has to like uh, move more slowly as it makes the turn,
Uh-huh.
and then come back around. So as we come to the standstill at the solstice, it's at its slowest change of day rate, but when we come into the equinox, I think it's at its fastest change of day rate. That's why I think it's getting so much brighter so quickly right now.
Oh.
But I want to look that up again because I think I've been told the opposite of that once before too. Not to change the subject though. So as the day is getting progressively brighter right now, that's because we're making more motion on the ecliptic. So what we're seeing is the ecliptic rise out of the southern sky, or out of the south side of the sky, from our perspective in the northern hemisphere. It's rising up further to the north and further up toward an endpoint like due west and due east, which I think would be essentially what an equinox is.
Yeah. When it gets to is it like when the sun gets to its furthest west
Well,
point
yeah, like I guess yeah, it's most like due west
or
point.
most
It's
due
center
west?
point because like there's
Yeah.
the north point in the summertime for June when it comes up super early in the morning and sets super late in the evening. It's coming up at its furthest north point. But here at the equinox, it's going to be about at the equal point it would be in the fall as it's coming back up from the south. So it'd be kind of that center point between the two, and that's what we
Oh.
make east west. And then we have like our furthest south rise for us in the northern hemisphere, like December 21st, and that's like the furthest south point. Um, so yeah, I guess as we're moving back into the equinox right now, things are moving a lot faster for us each day, and that's causing like Venus to move a lot closer to the sun as the sun's moving up from the horizon as our day is getting longer. Does that kind of make sense? Like if you were to think about the length of our day as it seems to be getting a lot brighter, a lot faster,
Mhm.
then when the night sky happens is going to happen a little later, or what's visible in the night sky is going to be kind of affected by
Right,
the
because
sun being up.
there's yeah, like there's still light in the sky.
And I think that's sort of affecting what we're seeing with Venus as it moves down so quickly. But to get to your original question, I think it was how many days is it going to be gone behind the sun before we see it?
Oh, yeah, yeah, how
And then
long will Venus be gone?
yeah, it's interesting. So what I've all just explained is to get to the point of to get to the point of that when we're next to the equinox, when we're moving quickly, it happens that Venus will move past the sun and out into the morning sky much more quickly than it will if we were close to a solstice and the same motion was
Oh.
happening. So all that long preamble was to explain that point, if it's helpful at all. And so it's kind of interesting that yeah, Venus will I think dip too close to the sun to see at around March 24th. It'll be gone for just a few days, and then I think you'll probably be able to see it again in the morning sky by around April 5th. Maybe even earlier than that. It depends, I guess, on how accurate you can be.
Okay.
But I think yeah, soon after that, it will be popped up onto the other side of the sun
And
in the morning sky.
does that count as a second time in its like 5/8 rule?
Yeah,
Is that like the second time that
yeah.
we've seen it
So we're
now
seeing time if we're
for this
counting
year
this one.
or for this? Yeah, it's
Yeah,
difficult to describe, I guess,
yeah. So
the
if
timeline
from
of
our
it.
perspective we're saying this is number one that we're
Mhm.
gonna wait to see happen again, then what we're gonna see is the end of number one happening and the beginning of number two happening
Okay.
right after that. And so we're gonna see it's one motion in the morning sky, or yeah, in the morning sky now as it comes up and then comes back down to the horizon, and then we're gonna see it throw again,
Into the night
yeah, into the
or into
evening
the
sky.
morning.
And yeah, it'll be interesting to watch it go back and forth, but we'll keep up with it a little bit more. But yeah, so right now it's just going to be a few days that it's behind the sun, and then back up in the morning. I think we're going to get to see Mercury too.
Oh, cool.
Another subject, but if like maybe what we'll get to observe also is as Venus comes up in the morning and then goes back down to the horizon again. It's going to be maybe 9 months from now, which might be close to the winter. So we might be able to get have a chance to describe the motion of it near a solstice, like what we were just talking about. I've heard it can be up to like 5 weeks that it's not visible, like that it's
Oh.
behind the sun because the solstice is so much slower. It's everything's
Oh,
at such a
yeah,
greater
it's
standstill at that time. I don't know, really kind of
that's
trippy stuff.
interesting. Yeah, so what is there's kind of like an amount of days that it'll be gone between.
Yeah, it
So like
seems.
it's going to be at least so many days that it's gone, but not more than this many days that
Yeah,
it's out of our
there's
sight.
there's a few different variables that I'm not 100% sure on, but it seemed like the maximum was sometime around 5 weeks. It was like 40 days or something like that.
Wow.
And then the shortest is like 4 or 5 days.
Oh, wow. And that's probably closer to what we're going to have this time.
I think so. Yeah. And I know there's a few eccentricities of a few things that could
Hmm.
be going on, but I think generally, yeah, this is going to be a quick one as it rips right by, and then
That's
it's back up.
cool.
Yeah.
I want to I want to make sure we get to see it
Yeah,
happen.
yeah. We should talk a little bit more about it as it comes up because I know there's a few other myths attached to this motion that we're talking about right now, and I wanted to get into that, but I don't know
Yeah.
if I have I don't have enough research for it. But a lot of the old Sumerian stuff has a lot of stuff tied into Venus and this motion we're talking about, and a lot of old Mayan or anthropology has a lot of information tied to Venus too, which I think both of those have some cool facts to kind of go over and
I think
things
that
to
would
talk
be
about.
really cool. Yeah, I think that there are a lot of really interesting anthropological parts about it.
Yeah.
I was starting to read, or I'd gotten into the part in the book that we're reading through where it's talking more about the Mayans and
Oh yeah, isn't
kind
that
of
stuff
their,
interesting?
yeah, it is. I think it'd be really cool to
Yeah,
talk about more as we
yeah. We should break that
are
down,
observing
look
Venus.
at it, and we should definitely come back like in the next week or two, like as we're watching
Yeah,
this
as it's
progression
happening.
of Venus. Yeah, we should talk about that stuff a lot.
I think that'd be really cool.
I think it'd be so cool, Marina. But yeah, thanks a lot for doing this podcast with me.
Yeah, thanks for doing an episode.
Talking about some Venus observations that we were making.
Yeah, it's cool seeing it.
It is,
I'm really
yeah.
glad we had that clear night a few
Oh
nights
yeah, I
ago.
know. It's so
It's
frustrating.
annoying. Yeah, it's
Uh,
annoying
I just want
going
to
a while
see
without
all
getting a
the
nap.
cool nights.
Oh yeah, it was cool seeing like just Orion and the other
Oh yeah,
constellations and stuff that are coming into
yeah.
this
Comparing
this
that to
season, and
Mars, that was
yeah,
cool. Seeing how red they were. Was more red.
yeah,
Is that more red? Hmm. But it was,
so
yeah,
red.
really cool. I like that stuff a lot. So yeah, I'm really I'm looking forward to March, and or at least hopefully it gives us a break, and at least April and May when we get back to having some nice observation nights. But we're gonna
I'm
take advantage
excited.
of it so much this year.
Yeah, we are.
It's gonna be great. So yeah, guys, thanks a lot for listening to us do a little podcast about some space stuff. I appreciate it, Marina. Thanks for doing this podcast with me.
Thanks, Billy. Thanks everybody for
Yeah, thank you guys
listening.
very much. So, on behalf of Marina Hanson, my name is Billy Newman, and thank you guys very much for listening to this episode of the Night Sky Podcast.